Welcome to the lecture videos on modulation in our Signals and System course. These slides in this presentation is made by Khaled, Elmalawany, Josh Duha, James Chen, and Nolan Litwin. So we're going to do a brief introduction on what modulation is. We're going to go over the types of modulation present in our world and how we use them. We're going to go more into depth on amplitude modulation, how we modulate a signal, its form in the time domain, its form in the frequency domain, and its phasor analysis. We're also going to cover some of the modulation circuitry that we will use. So this includes the modulator circuit and the demodulator circuit and the various forms of that. And finally, we're going to cover alternate modulation types. So this will include double sideband and single sideband, and their benefits and drawbacks. So we'll do a quick overview of what modulation is, and then we'll get more into depth. So, what is modulation? Modulation is very similar to a transform. It changes signals into a form that are more easily transmitted. They are very common in the communications industry. This ranges from your radio to your motor or any motors that you may use. And it is pretty much a way of completing data transfer. Most modulation embeds the message signal into a blank carrier signal that we can then modulate and then demodulate at the other end. So this block diagram shows the simple idea of modulation and the process of modulation and demodulation. We have our message source here, so this could be, for example, your voice. This will be inputted into a transducer. This might be a microphone in a voice microphone example. This basically converts whatever your message is into your electrical signal. Once you have your input message, which we will set as M of t, it will be inputted into the modulator, which embeds your message signal with your carrier signal, in this case xc of t. You'll transmit the signal into your channel here. Naturally, in your channel, you will have some noise and distortion. Once we retrieve the signal, we will demodulate it. This is the process of extracting our message signal here. So we want to separate our message signal from our carrier, x of c here. And then we will have our message signal. We can either output this to a transducer, like a computer speaker, or anything else you may want to output your signal to. So we will go over quickly the basic families of modulation that we have. There's many different types of modulation, but typically they fall into one of three families. So, as you can see here, we will slowly cover all of these families throughout the video. First, we're going to cover amplitude modulation or wave amplitude modulation. This involves the typical AM modulation. There are variants on this, including double and single band. There is carrier suppressed modulation, and there is also a method called quadrature or multiplexing, in which we more efficiently utilize the available bandwidths and embed more information into a set bandwidth. So this is the simplest and oldest type of modulation, in which we embed the information into the amplitude of our signal. The basic idea is we're going to multiply our signal into a sine or cos wave, and then we will get our output signal. Again, this can be employed with quadrature AM in order to make better use of the bandwidth that we have available. So as you guys can see, in this case it modulates AC, or the amplitude here. Next, we're going to go into some of the wave angle modulation methods. we're going to first cover phase modulation. Phase modulation is when we modulate the, obviously, the phase of our wave, as you can see in this image here. It's similar in AM that it's still using the sinusoid, but instead of modulating our amplitude, we're going to modulate our phase here. We do need to find the instantaneous phase of the modulated signal, but we won't go too in-depth into this. We'll mostly cover AM modulation. Next, we also have frequency modulation here. As you might have guessed, in this case, we are modulating the frequency here, and that is how we are going to embed our information. This is significantly more complicated than AC. This is significantly more complicated than AM modulation, but it is very commonly used in modern communication systems. Okay. Next, we will cover some of the pulse modulation methods. This includes pulse amplitude modulation, in which we are simply modulating the amplitude. It's very similar to AM, except in this case, we are going to be using a pulse train as our modulating carrier. We have our input signal, our sample here, and then our PAM signal here. This is a very common step in ADC, so analog to digital conversion, and it results in a pulse train. You may have seen this in ENCM in one of your PIC labs, I believe the second PIC lab. So next we will cover pulse width modulation. Keep in mind this is the width of each pulse that is modulated to encode the information. This does not change the position. That is a different type of modulation. So each pulse will still be centered at the same point, except the width here will be modulated. This type of modulation is very commonly used in motor controllers, in which we pulse the motor on and off at a set duty cycle, so a certain percentage of the total message, which turns the motor on and off for a certain set amount of time. Our next modulation method is going to be pulse position modulation. This is generally done by making equal pulses at the start of the falling edge of a PWM signal. This modulates, as you may have guessed, the pulse position in each one of the signals. This is commonly used in deep space communication systems as well as fiber optics. This is much more complicated than the other methods because it requires a very accurate synchronicity of the receiver and the transmitter. If the receiver is even slightly off on the frequency, you won't be able to read your information at all. Finally, we have pulse code modulation, which is when the message is encoded into individual pulses. These pulses are all quantized to be either on or off and are very applicable to binary systems. This is similar to pulse amplitude modulation, except of course the levels are quantized to 2 positions. You may have seen this in the DAC lab in ENCM 369. So now we have gone over our quick introduction and a brief overview of the types of modulation. In the next videos, we are going to be going more in depth into amplitude modulation, and then we're going to go more into the circuitry involved in modulation and demodulation, as well as alternate amplitude modulation types.